get started here in just a second. Oops. Okay, sorry about the delay there. I was just trying to get Slack to comply with my... So last time, none type. So let's just start with integers. So yesterday we talked a lot about the various scalar types built into Python. Integers, floating point numbers, Booleans, and strings. Integers are what you'd think of as just positive or negative whole numbers. Here we have just some examples of variables pointing at integers, incrementing the values of those variables, etc. Converting input to an integer. So remember, the input function prompts the user for input. The prompt displayed is what's passed to input, but input returns, it actually returns a string, and we print off the type of that, and then we convert it, and we just cast it as an int. We say x equals int of x, and if we didn't pass in an integer, this would actually throw an error. But if the string is a string of digit characters only, then it will be able to be converted to an integer, and this will be successful. So this is important to know, not necessarily in the context of converting something from input, but converting a string. There are times when you will have a string of numeric characters that... All right. The integer downs. Yeah, this is what I want. Oh. All right. So there's going to be times when you're going to get a float value that is approximate, that is like approximately equal to a value that you need. That's an integer. You need to convert it to an integer. So if I have some calculation that results in, let's say, 4.0038712 or something, I might just want to treat this as 4, so I can just cast this int. Oh, come on. That autocomplete feature is annoying to me. Print. All right. run this. When we cast is going to be just truncated, and we'll end up with only the whole number value, whatever that was. Oh my gosh. Sorry, my computer is just kind of acting a bit slow. Let me see if I can free up a little. Maybe that'll make a difference. Okay, so this is a useful thing to remember for integers. There are times when you're definitely going to want to truncate values in this manner. It's not one thing, it's another. Let me just take care of this real quick. I'm just going to start a thread in the Slack. Just going to close Slack on the machine. There we go. Okay. Hopefully that'll free up some resources. And I'll be monitoring Slack on my phone here. So okay, so using integer. Okay, float. So floating point numbers can be thought of as what we would commonly refer to as numbers with decimal places. It's in programming we need to be able to understand numerical different context, just deal with numbers in a base 10 format, and that is the assumption, you know, like if I'm typing a number, you know, Python. But since other bases do come up, we still want to be able to refer to that is explicitly implies, well, explicitly implies decimal isn't associated with any specific base. It's not that common, and we won't be getting into like other bases here, but you probably will encounter hexadecimal notation at some point, which is base 16, and that's really just a way of representing binary data in a more condensed format. And there are other bases that you may encounter just doing various things, but so that's why we call them floating point numbers. And basically it's called that because we have this, whatever this number is, and then we have information that tells us where the floating point is, right? So this point can quote unquote float between, or it can even be, you know, whatever. So floats are held in memory. They're, let's see, how would I so let's look a little bit at floats. We can convert string, returns a string of digits. Python can actually, that's intended to be made. This is just the limit of your hardware being able to just not process a number that's that precise. Extremely precise number. And there are ways, there are like more complex data structures that can extend the even more precise. This is just the amount of precision that your CPU can. Doesn't come up a lot, but it's it's worth knowing that it can happen and just keeping in the back of your mind. Unexpected can be hard. It is something that can happen. On to Booleans. So Booleans are simple in terms of what types they can represent. So we have Booleans can either be the two states and integers or states, and we're using Booleans to control their conditions, right? So if I say if, let's say a equals 11, so a gets 10, b gets 11. So if a equals b, we can print a is greater than b, a is greater than b. Let's say if LF a is less than b, we'll say a is less than b. Cool. So these expressions, what's known as so in this case, a equal to b, does that express the value true or the value false? And this kind of coding or a lib, so equal, that compares the left-hand operand with the right-hand operand, and it will, if they're not equal. In this expression, a equals, so that's what then it'll print, right? Because I just wanted to give it something that we could, it'll check if, so the body of this condition will also not be executed. And then it'll check if a is less than, anywhere where you see this double equal or greater than or less than, those will express a Boolean value. There are some others. There's less than or equal to. Actually, let's list them all. There's equal to, not equal. These are the sort of Boolean comparison operators that you'll use a lot. These top two can be used with anything that's not an integer. Between is the string hello equal to, this could also say if the string hello, this will also be true, right? Because it's true that the string hello is not equal to the string goodbye. That would be false because they are equal. Cool. I can't compare a string or anything else other than a number like greater than or less than, because a string is not inherently greater than or less than another string. Let's say I said 1 billion. That's a big number. And then if I say 200, on what basis do we tell whether one string is greater than, these aren't numbers, right? So we can made on the length, on the basis of the length. If you do want to compare the length of strings, you can convert their length. You can just ask to compare the length. You can say, give me the length of this string and the length of this string. And those are going to be integers because you use equal to and greater than or equal. There are other things like sum that will give us numerical values based on the contents of a collection or something. Cool. There are some other Boolean operators. It takes one operand on the right-hand side, and it's an operand that either evaluates, likewise, I always try to explain this, and I always forget the example. I need to just write down an example of this. There are cases where it's easy to compare something. It's easier to do one that easy execute true. It's essentially, you can also do things like actually, I'll just do this. I'll try to make this relatively straightforward. You can also do things like checks for membership are Boolean expressions. So let's say I have a list that contains 3, 5, and 8, and I want to see if 7 in my list of 3, 5, and 8, and we know this is false. If 7 is in the collection, then we'll print 7 is in the collection. The list there. So I'll just run that and we'll see the output in a few seconds here. Oh, of course I didn't actually ask for any output. So if I find myself using this element is not a member of this collection, then you have some code to execute. That can be very useful. And still Boolean operations, and evaluates and expresses true if it's left and right hand operand, evaluates to false. So let's look at this. If I print true and true, oops. False and true is going to be false. False and false is going to be true. False. Ugh. So this is just a true. We can use a. Let's say if a is less than 11, b is 11, and 10 is greater than 8. When I have and like this, doing expressions like this, when you're using and or, wait, rephrase that. When I'm using and or and not, I generally will use parentheses around the operands, just so that will be, if you just kind of write them in the right way, but sometimes that can get a little confusing. So in this case, I know this expression, a is greater than 8, is going to evaluate, and then whether that's true or false is going to be fed to and as the expression operand in the and. So if that's true, then we'll print the truth table for or is going to be true or, oh, come on, false, right? So or give back true if either or both of its left and right hand operands are true. So the left or the right is true, then it'll evaluate to true. If they're both false, then or will evaluate to false. In reality, so when you're and gives you a headache. I think every type in Python can be cast to a Boolean, and so every type has either like only as one. So for the integer, so was the every other state. So even negative numbers, even, and let's do, of course, positive integers, right? So all of the rest of these, you know, if they're not exactly 0, then they're going to be truthy. So it's a bit of an odd behavior, but it can come in handy. And it can also, if you're not expecting it, it can also cause unexpected behavior. Remember that. Real pearl of wisdom. Cool. Okay, what else for Booleans here? Let's see. Strings. Let's do casting a string as a Boolean. Oops. Let's just go to there. So a string, if the string is empty, it's falsy. If there's anything in it, including a space, or let's say a tab, or a new line. Actually, let's just do it this way. New line, \n. So these are white space characters. These you might think, oh, these are empty. These are not empty. These contain characters. They are invisible characters. They're not represented by characters that you would say that you could see, but they are characters. They are UTF-8 encoded characters, and they are not empty strings. Empty string is a valid string, but it contains no characters. An empty hello, that's going to be truthy. Yeah. Cool. So we haven't really gotten into lists yet, but anything in it, one item or, you know, true. Even what? Pretty sure that's true, but now I'm second guessing myself. We'll see. 1. We're seeing if the list that contains 0 is truthy, right? If we even do this, the list will still be truthy, even though it holds a falsy value, and obviously false is pretty falsy. So since the list is not empty, even though its value is falsy, the list is truthy because it has something in it. It's non-empty. So, and you can carry this logic out to dictionaries and sets, but I think you get the picture. I'm not going to demonstrate those because we haven't really talked about those types yet. I already said, but cool. No, there's those. In a nutshell, I'm just going to be real quick about this. There's the comparison operators: equal, not equal, less than, greater than, and then the sort of the combination of these two with the previous two, greater than or equal. Then there's not, which inverts a Boolean operation. These last three, just whatever operand you're feeding them. I suggest just use parentheses. So I like to use them in this format. I find that what I'm trying to accomplish practice. And then with these ones, we'll just do this. You can use parentheses if you want, but you don't have to. These are your operators. We talked about how each of those work. These top two and the bottom three you can use with any type. These less than or greater than ones you can really only use with numbers or actually other Booleans. Let's see. Falsiness. Truthiness and falsiness. Those are the takeaways from this. Oh, God, I feel like I'm missing something, but whatever. Let's just comment this out. With a lot of implication about how to deal with numbers and true and false values. But we obviously will want to deal with text. A programming language should be capable. So I think every other if you can prove it, and I'll keep my words on it. Types in Python can be represented as strings, can be cast as strings. So they can be useful when you want to deal with the textual representation of another type, and there are times when you might want to do that. They can also be, obviously they can be useful when you're dealing with just text. One of my favorite sort of exercises that I do with a lot of students is I'll just copy in a little text. Stopping by woods or something. It's a Robert Frost poem. But I just use it just because it has a number of repeated words. It has some capitals and lowercase. It's not a huge body of text, but it has enough variety and enough redundancy that it's a good. And we can there's obviously times in data science and just in general programming where you want to do, let's say I want to just print out the length of every word. So I'm going to do for word in text dot split, and that'll give me an instance of every word. And then I'm just going to print len word. Let's give that a second to run. Oh, shoot, I forget that keeps doing that. Okay. So you can see we got all the length to do with text. So strings, we represent a string. I'll just comment this out for now. We can represent a string by surrounding some collection of UTF-8 characters with either double tick quotes or single tick quotes. I think everybody that I work with uses single tick quotes. PEP8, single tick quotes for strings. I don't do that. I use double tick quotes because I like them better. The reason is I find myself doing things like contractions like th. They said, quote, I'm going to the store. Yeah, I even used a contraction here. Okay, so I find myself using contractions more than using an apostrophe more than I just use double quotes for strings. So I do depart in my own coding with PEP8 in this regard. And this is, I just say this to take the opportunity to say, like, you don't always have to follow like style on things. What's important is that you basically stay consistent. There are times where I will use single tick quotes for a string, but it's the exception, not the rule, and I don't mix and match them randomly. That's my preference. Experiment around and see what, and then just sticking with that, just so your code looks and feels and reads consistently, and that's always nice to have that feeling of like your code reading well. So cool. You can also spread a string. If I want to like represent a string over multiple lines in my text editor, if I break it up across multiple lines, so this is white and this is green, and right. So what you can do is up a string over multiple lines. And some of you might be saying, well, isn't that a multi-line comment? And the answer is yes. A multi-line, that sort of begs the question, like, well, is a single line comment also some kind of string? And the answer is no. A single line comment, these line comments literally are multi-line strings. They are one and the same thing. So that feature is used in multiple ways in Python. Watching me, because they can comment out they don't interfere with triple single quotes for multi-line strings. So if I'm leaving documentation in my code, I probably am leaving it in a multi-line comment string like this, and I'm using triple single quotes so that my convention, I don't know anybody else that uses comment block quotes. My preference for multi-line strings for actual valid code is triple single quotes, and I use triple double quotes for the comment blocks because they don't interfere. So that's my thing. What else do we need to know about strings? Declaring a string that's equal my string equal banana. Print my string. Let's see if I can type all the characters. Cool. Identity. Okay. Oh, gosh. Hello there. That's the greeting. And I'm a banana is our identity. If I print a greeting, I can add it to another string, right? So I can use the plus operator in this manner, and we don't call this space between those. So this is how, and let's just save that in another variable. We'll say my string equals greeting plus identity. Let's play around a specific substring in here. If I want a specific character, I can count from the left to the right, and we'll look at this example down in the term. The first 0th character, right? So if I ask for string sub 0, I'm going to get H, right? So the numbers in the string, the number that corresponds so it's kind of funny. You want to widely adopted programming languages use what's called zero-based indexing, zero-based counting. I'm going to do index space. Good. So H is, see, I started at 1. H is 0, E is 1, L with its own index at index 5, and then T, right? So H, E, L, L, O, space, T. Even though the T is at, it's the 7th character in, it's at index 6. So at index 6. So that's kind of a, I would say, and I know what I need to end up with. Just guess what I want, and it's going to give you that H, actually, and obviously, I don't know why my code is taking forever to run on this machine, but it is. But we can look at that, and we'll get the H after that T, and then we can say, oh, I guess I wanted the T. So you can kind of guess your way there if you're still trying to get used to zero-based indexing. That can be a funny one. We can also ask for like a range, a portion of the string called a substring, right? So if I want to say, if I want to print like, let's say there I'm a, right? So I know that there begins at 6, and I want to end it at 7, 8, 9, 10, and then I have a space. That's going to be 11, 12, 1, 2, 3, 4, 12, excuse me, 12, oh gosh, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Gosh, okay. So that's index 16. So I'll say, so what I'm doing here, and that'll give me like a range of values, right? So we can specify 3 things in a slice. We can specify the index to start at, which is included. If I say by the index to stop at, which is exclusive, it is excluded. So if I say index 16, it is going to go up to index 15, and it's going to stop short of index 16. It won't include it. So I'm going to say index 16, and I want to include index 16, so I'm going to say +1, right? And obviously I could just say 17, but let's say, uh, I have some outside variable or something that might change that's going to tell me where to stop in my greater coding logic. So I'll say stopping point equals 16 and as 16 from some other source, and stopping point plus 1 is going to actually include where I wanted it to stop. It's going to go in steps of 1. Every other character. 1. This is going to give me every character backwards. It's going to give me a reverse range. So 3 on that. All right, so that's strings. One second here, folks. Okay. I think we can skip the challenges since we went over those yesterday. Cool. So the none type. Well, there's function before. What's happening there? That's what I wanted to do. Okay, there we go. All right. We talked a little bit about functions before, so I'll define a simple function. Def print arg we'll say print arg plus 10. Print arg plus 10. We'll take in a number. We'll just call it print in plus 10 because that's what we're doing. And we're going to print n plus 10. So think about this. If I print off the value of what this function is going to be, and I say I want to know what 20 plus 10 looks like, this line 61, is going to print none. And that's because this function doesn't return anything. We didn't ask it to return anything. Now, in Python, every function has to return something. If you don't specify a return type, it's going to implicitly return none. And that's let's write factorial like this. We have a factorial function, and we'll say prod equals 1 for num in range 1 to prod. Oops. I want to include it prod plus 1. Prod times equals num. Problems like this, and they're like, I'm submitting my code in Learn or on Code Wars, or I'm trying to do something and it's just not working, and I'm getting like, some error that says, type error. So in this case, we're not asking this function to evaluate to whatever the value of prod is, right? In order to do that, we would have to say return prod product. Its output is whatever the value of product is, right? So return gives the function a value. When the function is done executing, when it encounters that return, it finishes all of its uh, it finishes executing any code inside of it, and it gives that value out, and that value can be used wherever you have that function, right? If you don't have that return, your function is going to return none. So function or something, and I have like factorial 4 over and you want these values. You want the function to take in a value, make a calculation, and then give you a value back. But this function does not give a value back, so it's important to know that. We're going to get an error here, and we're going to see what error Python gives us. There we go. So we get this type error. So I've talked a little bit about this, but this is a good time to touch on it. I used to do, when people would tell me that, I'd be like, okay, I would scroll up to the top of the error, and I'm like, okay, so type error, / projects, Python main py and module, line 7, if, you know, and I'm going through and I'm reading supported operand for type / none type and none type. And then I would read the last line, and I'm like, okay, finally, I think that will tell me what's going on. So when you get an error, it's usually a better practice. If you write some code like this, start at that last line where it says type error. So this says unsupported operand for type, unsupported operand types for /. And then it's going to tell you what it found on the left and the right-hand side of the /. None type and none type. So it doesn't know how to divide none by none. None is not 0, right? And obviously we couldn't divide by 0 anyways. That's a different kind of error. It's a 0 division error. None is 0. It's not thought of as like an empty string. Those are different types that have empty values or 0-based values or something. None is a value that is not a value. So it's even more 0-y than 0. Okay. So, in order to fix something like this, we can return prod. This code will execute and display after several generations of waiting because it's being slow. Cool. Wait, really? I get 1.0? That's crazy to me that I actually just ended up with 1.0. That's something weird, really weird. I think I must have made a mistake. Now I'm all curious. It's worth it. Because if you're new to programming, this is a good opportunity to see, like, all right, that'll do it. I just put in the wrong variable name there. There we go. That's the weird beastly float that I was expecting. Okay. So takeaway from that is functions return none unless you specify a return. So let's read this. None is a special type in Python. It is not the same as 0. It's not the same as false, although it is falsy. It's not the same as an empty string or any other value that has been covered. None describes the absence of a value. Yeah. Default return of the function. This is an example of what I was just talking about. So we can use none as a placeholder. And there are times when you want to do this where you have, you know, a very you don't know what it's going to be. Turn it into whatever you need later. Let's look at what the example they're giving. Placeholder, it's likely that you've already in snippet will throw an error, right? So you can't just so we can give it the value of none if we don't know what it is. Oh no. No. Chrome. Basic Computer Usage 101. That's the name of this class today. Okay. Encountering the none type as a data scientist. It's common to come across data sets that are incomplete and collected at a given time. At other times, there may be properties of a data set that aren't relevant or that are filled in certain places but not in other places, etc. Consider a data set that describes scientific research is the country where it's located. However, there are locations in Antarctica that are not annexed by any nation. How might a data collector deal with this scenario? A best practice would be to have an explicit code blank. When reading in data with Python, missing data will be typically converted to a none type object. So this is a good expecting data here, make a decision here. Do you just like you could throw an error and just say like kernel panic or something. Did data point, I was expecting some data here, I didn't find anything, so I'm just going to assume that it was none and I'm going to move on, right? So that at least, it's still something that you may have to handle, may have to deal with. It might cause other kinds of problems, but at least your program keeps running and you can handle those problems, do whatever. None. So true or false? Like that. A none type object is the same as zero, false, empty list, or empty dictionary. Well, that's going to be false. So the none type object can be thought of as explicitly empty. It is explicitly not any of those. It is not implicitly any of those. It is not analogous to any of the data types or values in the prompt. Which of the following is not true? None type objects are not yet defined, or not yet defined or calculated. The none type objects are often used where data is missing from the data set. That's true. None type objects are the equivalent of null or undefined in other programming languages. That is true. A none type object can be considered as a value that is explicitly empty. That is true. Once a none type object is assigned to a variable, it cannot be changed. This is untrue. Let's read this last one. None type objects are the default return from a function. That is true. So you can assign none to something and then you can change it later. Write a function called returns none. Okay, so def returns none. Takes no arguments. A function with literally nothing in it is just gonna, which is just a pass in it, is just gonna return none. Let's see if I just want to see if I can do it with a lambda, just because it. Oh, okay. I can't have a pass, that's right. Yeah, okay.